In the coming years, wind turbines will become larger and larger. Only in Europe, over 3,000 offshore turbines per year will be installed in the coming decade. With the increasing size, more noise will be generated. To protect marine life against this noise, the market screams for quieter installation techniques as an alternative to the traditional impact hammers. These still require expensive noise mitigation screens. GBM Works is on a mission to develop a sustainable installation and decommissioning method. We're currently designing the next version of the controlled jetting solution. And by controlled, we mean that we understand how the soil behaves inside and outside the monopile during installation, and what the possible bearing capacity consequences are for the design of the monopile. The current impact hammer is scarce in availability, and that drives up the costs as well at the moment. GBM Works is very proud that the current jetting solution, the Vibrajet, has been certified by DNV and therefore can be applied in the Hollandse Kust West for Ecowende in March 2026. GBM Works has started a new project, SIMPLECS, which is part of the SIMPLE program, a silent installation of monopile program, and it has the objective to install in high-density sand and high-density clay from 2028 onwards. We always work together with the whole offshore industry, and we do that, for instance, together with institutions like Deltares, where we are today, and often we are supported by the government and the EU.
I'm the project lead of Simpler, and in Simpler we explore the retrievability of the Vibrajet, specifically of the controlled jetting that we are performing on monopile installation, and that's what we call Flex, and this is one of the innovations in GBM Works. Here in Deltares we're setting the ground for the next project in 2026, which is called SIMPLECS.
Here at the lab we built a new machine to tackle a new challenge, tough soil condition, to upscale the GBM technology to the next level. So we have different techniques in order to penetrate through clay, for example. We are evaluating 3 techniques. The first one is the high pressure jetting. We have also cutting. We have a shaping technique, shaping of the clay, and we have as well additional variation of these techniques. We mainly use high pressure jetting combined with vibrohammer in order to penetrate through very hard clay. We can go up to 500 bar in order to penetrate through this 200 kPa clay. So we do that with and without a vibrohammer. And we're trying to build up a jetting model in order to get scalable results that can be applied in offshore conditions.
By December 2025, we're going to gain precious knowledge on retrievability and clay testing techniques. And this is the future not only for GBM, but for the future quieter installations in the offshore industry.
In the SIMPLEX project, already 6 partners have committed to join, and more are coming. If you wish to understand more about the project or you'd like to join, please contact me.